Hi, everybody, and thank you so much for joining me. So, today we are going to do lesson 3.2 rate of change and slope. And the standards is 8th grade California Common Core functions number 4. And what do you have to do? You have to be able to construct a function to model a linear relationship between two quantities. Determine the rate of change and initial value of the function from a description of a relationship or from two xy values, or including reading these from a table or a graph. Interpret the rate of change and initial value of a linear function in terms of the situation and models, and in terms of its graph or a table of values. Wow, that's a lot. But we got to be able to do it so that we grow our brains, okay? The essential question is, how do you find a rate of change or the slope? Do you remember that in seventh grade? From seventh grade, rate of change and slope. So investigating rates of change. So this is what a rate of change is, and underline it. A rate of change is a ratio of the amount of change in the dependent variable to the amount of change in the independent variable. This is what I like to say, is that the rate of change, or the slope rate of change, is equal to the change in the y divided by the change in the x. Okay, how much does the y change? How much does the x change? And that's the rate of change. Or instead of saying the rate of change, we can say slope. Slope is equal to the change in y over the change in x. So example number 1, it says, Eve keeps a record of the amount of lawns she has mowed and the money she has earned. Tell whether the rate of change are constant or variable. I'm going to show you a really easy way, okay? So what we do is we look at this. How much did it change from here to here? That's 30, right? 45 minus 15 is 30. How much did it change from right here to here? That's 2. So then I go, okay, the rate of change is 30 divided by 2. I put it right here. 30 divided by 2, that's 15. Okay, now I do this one. 45 to 90. 90 minus 45 is 45. From 3 to 6, 6 minus 3 is 3. Now I divide. What's 45 divided by 3? That's 15. Notice that it's the same right there and right there. Okay, now I go to the next one. From 90 to 120, that's 30. From 6 to 8, that's 2. 8 minus 6 is 2. And then I go 30 divided by 2, that's 15. Oh, the rate of change is constant. It's always 15. So I put the rate of change is constant. Okay, constant. It is $15 per lawn. Oops, $15 per lawn. Okay, so that's the rate of change. Okay, any questions? Let me know. Okay, on your turn. See if you can do it by yourself, and then you watch the video to see if if you did it correctly. Okay, so again, the table, you can pause this video. The table shows the approximate height of the football after it is kicked. Tell whether the rate of change are constant or variable. So I start looking at this one. How much did it change? From 0 to 18 is 18. From 0 to 0.5, that's 0.5. So now 18 divided by 0.5, that's taking half, dividing it in half. So then I'm going to have twice as many as 18. So that's going to be, what is it, 36? Because 18 halves, that's 36 halves altogether. So from 18 to 31, that's going to be, what is it, 13? And then from here to here, that's 1. 13 divided by 1 is 13. So I know right away that is not constant. But I'll just do the next one. This one actually went down from 31 to 30 to 26. That went down 5. So negative 5. And this one went down by went up by a half. So negative 5 divided by 1/2. How many halves of in 5? I have 10, negative 10. See, the rate of change is not constant. Find the rates of change. They are not, they're variable. Okay, so the rates of change were 36 and 13 and negative 10. So they're not constant, they are variable. Okay, explore activity. So this one says using the graphs to find the rate of change. Ooh, now we're using the graphs. So it says right here, you can also use the graph to find the rates of change. The graph shows the distance Nathan bicycled over time. What is Nathan's rate of change? And this one says from 1 hour to 2 hours. So then I look at my graph from 1 hour to 2 hours, that went from 30 to 15. So right here I put 30 minus 15, that's 15. And then 2 minus 1 is 2, so 15 divided by 1 is 15. Okay, now this says from 1 hour to 4 hours. So I'm going to use this one, 1 hour to 4 hours. Then it went 60 minus 15. Remember the change in y over the change in x. So 60 minus 15, that's going to be what? 45, I think. And then 4 minus 1, that's 3. 15 divided by 3, that's 15. Ooh, it seems that it's constant, but we'll see the last one. From 2 to 4. From 2 to 4 right here. So 60 minus 30 and 4 minus 2. 60 minus 30 is 30. 4 minus 2 is 2. So 30 divided by 2, that's 15. Ooh, that's constant. Recall that the graph of a proportional relationship is a line through the origin. See right here, this is a line. This is the origin right here. Origin. Explain whether the relationship between Nathan's time and distance is a proportional relationship. So it is a proportional relationship because it's a line, is a straight line that goes through the origin. So it is a proportional relationship because the line is straight and and it goes through the origin. So I know that it's proportional. Okay. Now it says, does a proportional relationship have a constant rate of change? Ah, look at this. This was proportional, and so it does have a constant rate of change. Yes, yes. A proportional relationship has a constant rate of change. Does it matter what interval you use when you find the rate of change of a proportional relationship? Well, look, it didn't matter which one we used and we all got 15. So no, it does not matter. No, it doesn't matter. Okay, just remember the rate of change is equal to the change in y divided by change in x. So just make sure that you use the same numbers and you put the change in y on the top and the change of x in the denominator. Okay? Now calculating the slope. Now you know that the slope and the rate of change is the same. So it says when the rate of change of a relationship is constant, any segment of its graph has the same steepness. See, it doesn't matter which one you use. See, it has the same steepness if I use these two. Okay, the constant rate of change is also called the slope of the line. So right here, the slope is how much you rise and how much you run. So this one, the slope is rise 2, run 3. So here for the slope, we usually use the letter M, 2/3, and it's positive because it's going up. Okay, the slope of a line is the ratio of the change in y, the rise, for a segment of the graph to the corresponding change in x. I don't like this formula. So what I do is I just say, okay, it's the change in y over the change in x. That little triangle means the change, the difference. How much do the y's change and how much do the x changes? You just subtract them. Okay? So looking at this one, find the slope of that line. Notice, how much do we rise from this point to that point? We rise 1, 2, and how much do we run? 1, 2, 3. So M, the slope, is rise 2 and run 3. But notice that the line is decreasing from left to right. You always go from left to right. It's decreasing, so the slope is negative. Okay, and I'm done. You don't have to do all these things. Just count it right there. Okay, so let me show you again doing this example. It says the graph shows the rate of change at which water is leaking from a tank. The slope of the line gives the leaking rate in gallons per minute. Find the slope. So they give you 2 points. How much do we rise? 1, 2, I have to count correctly. 1, 2, 3. So the rise is 3. The run is 1, 2, 3, 4. The run is 4, so the slope is 3/4. Okay? You can see the rise and the run, and it's positive because the line is going up from left to right. Okay? Thank you so much. And now you got to do the guided practice and the independent practice, okay? Thank you so much and have a great day.